Hello, I'm Diana Little, Principal Engineer with Xylem, a global water technology provider with a mission to help solve the world's greatest water challenges with innovation and expertise. We live in a world where analogies are often the best way to explain complex systems. Everyone loves a good analogy. It's storytelling at the picture book level, which aids understanding across diverse languages and backgrounds. Recently, when Linus Harkisson of Gravitee and I were preparing a presentation for Xylem's REACH conference, I came up with an analogy for the difference between synchronous and asynchronous APIs for an audience who needed to understand what APIs even were. Since Xylem's vision is let's solve water, my analogy is, of course, water-related. Synchronous APIs are like sending a bucket down a well, and when the bucket comes back up, it's full of water. You've implicitly sent a command saying, I would like a bucket of water, and you get one. There's a clear association between the request and the response. There's a rope holding the bucket after all, and you're getting the water from the well you dipped the bucket into, not some other well. You're at the top of the well, waiting on the water before you go off and do something with it. Asynchronous APIs are like a spigot. The water is there waiting for you to turn the tap on, and when you do, you have a stream to deal with. You could fill a bucket, for instance, and then turn off the tap. When you come back with the next bucket, you could turn the tap on again and essentially pick up where you left off. You can leave the stream running and put filters in front of it, or have the water run down different pathways into your garden. You don't have to keep on sending commands to, give me water. Instead, the flow is there to be tapped once you've established a link between the spigot and the water source, your pipeline. Xylem is a pretty big company, and it's one that has grown via merger and acquisition. We have an extensive suite of hardware and software products, all in pursuit of solving water. As a result, we have lots and lots and lots of wells. Each well is a little, or a lot, different from the others. Maybe you need a different size bucket, or you need a key to a lid, or maybe that well actually contains oil instead of water. Internally, we knew that access to those wells of information could very well be critical to enabling new solutions, but the access was disorganized, siloed, and inconsistent. You often needed to know the person to talk to get access to that data. One of Xylem's product suites is automatic meter reading, AMR, and advanced metering infrastructure, AMI, systems. This is the technology that replaced human meter readers on foot, starting in the late 20th century. In many ways, AMI is one of the original IoT applications, before that term was ever invented. Water, gas, and electric meters now participate in cell or RF networks, waking up and chirping their readings and events and listening for commands. In addition to the key billing functions, utilities can monitor their networks and use advanced analytics to find leaks, predict maintenance for pipelines, and remotely manage shutoffs and turn-ons. The data flows from the meters to our towers over a backhaul to a head-end system, which decodes, correlates, and reassembles the messages and extracts meaning from them, then flows onwards to Census Analytics, where it is enriched with customer data, and further onwards to our data lake products and other integrations. There are command and control messages that flow the other direction for two-way meters as well. These are all separate hardware and software products linked together with a complex chain of APIs, data models, flat file integrations, cron jobs, file drop servers, and database queries. Exactly what you'd expect from a complex system that has grown over time and through acquisition. There are APIs at every level, but they aren't managed. That's where Gravitee is coming into play. We have customers, internal and external, who would like to tap into the data at points along that pipeline. We started discussing this particular need with Gravitee in 2021 and discovered that their roadmap and ours were well aligned. Our next generation head-end is built on an event streaming architecture using Kafka, and therefore each step in the data pipeline has a Kafka topic associated with it, which can be tapped into via an asynchronous API. In discussions with Gravitee, we realized that we could use their platform to solve not just the legacy API management problem we already had, but also open up access to the new data stream in a way never before possible. It's important to us that Kafka not become another database as API situation where applications are given direct access to the platform. We need to manage access, define consistent and documented APIs, ensure security, and version the APIs so that the underlying head end can change without forcing API consumers to change. Gravitee allows us to do all of that easily. We started using the async API capabilities with the 3.20 release, and with the 4.0 release adding the UI, it's become very easy to add new APIs on our tap points. We've created custom policies to do things like transform protobuf into JSON and apply filters to the APIs and transform headers. We ensure all users are authenticated by the Xylem identity provider. In this demo, I'm showing a fairly common use case for a utility customer. I'd like to monitor the reads and events flowing out of the head end for a particular list of bellwether meters. Perhaps these are meters at a local factory, or a set of meters that have been identified in the past as potential problems when seasons change and vegetation interrupts the network. So I'm going into the developer portal, and I'm going to search for the API. I have already created these because it's kind of hard to create a brand new API for a demo. Excuse me. You can see you've got the name, description. I've got it within a category, so it will show up in the portal. And the plans that I have attached are the XGS plan, that's our Xylem Identity Manager, and then a keyless API, just because this is for a demo and for development. I would remove this keyless API before deploying to production. For entry points, I've selected HTTP GET and WebSocket. WebSocket is the one we're going to use for the most part. GET is there mostly for troubleshooting and debugging. And then the backend services is Kafka, and it's quite easy to configure the Bootstrap servers. We have our gateway deployed locally, and it is behind a security boundary. So there is no specific security at this level. And you pick the Kafka topic to use. The Policy Studio, this is where I really do have some fun. I've added a bunch of filters for the stream so that you can connect and only receive messages for a given customer ID or a list of customer IDs, or you want to filter out excluded customer IDs. That one's important because we do use some customer IDs as sort of test tracer bullets, which would not be valid data. And the message filtering is the one that I use for the most part, but these are other policies that are available for the subscribe phase. Again, we have done a custom protobuf to JSON, but it's not showing up here because I had not deployed it at the time that I recorded this demo. So message filtering, let's go into this one. And the most important and interesting part of this is the filter condition. This uses an expression language, based on Spring expression language spell, which uses a lot of the basic Java methods. So it's not too difficult to figure out, although that's generally what takes the most time. This one is adding all the headers. This one is kind of important. It's a filter parameter, so you don't have to have it, but messages by their nature have all the headers stripped out. So if you really want all the headers, you can assign that content into the message when the parameter is include headers. This one, the messages did not have customer ID and radio ID in them, so I forced them in there. And now we're going to go look at the Reads API, very similar to the Events API we just looked at. But this one does not yet have the policy that is for our use case, the filtering by a list of radio IDs. It has all the other ones. We're going to add that filter by a list of radio IDs. My manager has asked me to add certain filters recently and asked how hard it would be. And within the meeting, I added the filter, which made him pretty happy. 10 minutes to add a new kind of API filter is a really, really impressive feat from where we were before. So again, request and response phase, I haven't yet found a good reason to use those because it's only on connection. And with WebSockets, those connections could be really long-lived, but I'm sure that there's a good reason for them. Filter by that list of radio IDs. And we have the filter condition. I did figure out that spell ahead of time, because again, that's usually the most difficult part. And it's basically looking within the header to see if the if it matches what's in the list of radios on the parameters. Add that policy, save it, and publish it. Deploy it. So, next we are going to look at what it's like as a consumer of that API. So I'm going to go into the portal. This again is our dev environment, so it's not necessarily as organized as a production catalog will be, or is. I mean, we do have a production catalog. It's pretty small so far, but XylemFlex.ami, there's a lot of the network APIs. These are pre-existing APIs, but they are now available in Gravitee with clear access URLs, descriptions, and Swagger documentation. This is pretty exciting for us. Includes, of course, the schemas as well. But that's not the one we're looking for here, so just wanted to show what that looks like as a consumer. Usually has some instructions on how to access, and then you can subscribe and create your application. So now we're going to search for the ones that we just created. And at this point, documentation had to be added by using the Gravitee API itself. So I didn't show that step, but it was not that difficult. And I believe they have added it to the UI by the time this will air, which is great. And for these APIs, I just added a simple README. Swagger doesn't really make sense for WebSockets, but there is an open API spec that I could use, and I will in the future. Describes the filters, gives a couple of curl commands for testing it, including that you have to go through XGS And I have a test application using WebSockets in Angular that I'm going to show next, actually. This is internal for developers, so it's important to give them an explanation of how to use WebSockets effectively. So I've already created an application here, but I'm just showing the steps of what I would have done to associate the subscription with the application. One of the things I find a little hard to understand and somewhat magical is that it's the presence of the application that allows you to connect to the WebSocket. And here I would put a client ID if I were using the XGS identity provider. But that association of the application with the API is what allows Gravitee to act like that spigot, and when you turn off your connection and then reconnect later on, you'll pick up where you left off. So that's pretty much me as a consumer. And now I'm going to move on and show using the API in an application. So this is a very simple Angular application. It basically takes that WebSocket connection string, and you can add those filters and parameters in. You hit the go button, you connect, and it will start consuming messages off of that WebSocket, and just kind of gives a little graph of the messages it's getting and shows the most recent 10 messages. Again, this is just a demo app. And we're going to use that list of radios and see what we get. Takes a couple seconds to establish the connection, and then since again it had been a little while since I'd run it, there were a bunch of messages waiting in the queue for me to consume, and it looks like of my list of radio IDs I'm only getting messages for this one radio ID, which makes sense. This is our tracer bullet. But it does show what those messages look like. And you'll see at the top there's the customer ID and radio ID. Those elements did not exist in the message. Those were added by the policy that pulled them from the headers. So now we're going to look at the same thing but for the readings. Apologize, I have a cold. Okay, we're going to look at the readings, see what we get. Again, a few seconds to actually establish that connection. Oh, okay, so we got some messages from that list. And these are reading messages. It's kind of in JSON. Again, very simple application. Really more for education for the developers than anything else. I think I had one more thing to show, the include headers. So including headers, is an interesting thing. Stop, restart. Wait a moment, and we were connected, so sorry. And then you see all of those headers coming in. So I find that the policies are really quite powerful. I've used a whole host of policies and transformations in the traditional APIs to reformat that output in ways that are expected. I find it's a really good way to even kind of skin an external API in a way that it's expected. And that is my demonstration. So I think now, starting over. There we go. Thanks, and I hope there are some interesting questions now. Appreciate it.